Hi, welcome back to this class. This class is about transformer, and transformer we have encoder and decoder. Here we talk about training and testing in encoder and decoder, and we try to give you an example. And our previous example was about a sentence. I like Rojava in English, and we tried to translate it using transformer encoder and decoder into Arabic. أنا أحب Rojava. This is the final output from part 9 decoder, the last stage, softmax. Uh, and you can see the probability distribution for token S and token ANA and token AHAB. And you can see that if we sum up all these features in each row, we should get equals 1. So for example, 0.105 plus 0.331 plus 0.116 plus 0.265 plus 0.181 should give you, some of them should give you 1. And you can see the bold one means that token ANA was predicted when we entered S start token. We receive ANA word predicted, and we receive ANA word predicted when we will submit or we enter ANA. And this is kind of wrong. You shouldn't have this output in real life. But we had it in this example because simply we took an example for learning, for teaching, and we had weight matrix output kind of simpler version of the values that we took. So that's why, in each row, it was predicted Anna, and it shouldn't. That's the idea for it. Now, this is the encoder part, this is the decoder part, and we are trying to show training time mechanics. When we talk about training, it means teacher forcing. And when we talk about testing, we talk about inference. Now, in the training, the whole ground truth target sequence is fed in parallel. For example, start token, Anna, Ahab, they're all in one sentence will go by using causal masking. And I talk about causal masking later in the later slides. But then during testing during testing or inference, the process works differently. So auto-regressively, the model predicts token by token, so word by word, feeding each predicted token back as input for the next step until it predicts an end sequence token /S. So for example, if you enter S, the predicted will be Anna. So start token will be entered, and then the system will predict Anna. Then for the next time, Anna will be added to the input. So your next input will be start token plus Anna. So here is the goal. We translate I like Rojava to Arabic or into Arabic using a trained transformer and using causal masking. So the input source is I like Rojava 3 tokens, and the target output will see generated step by step. Now, step 1, we run the encoder, done only once. We said that the whole sentence, this is not, this unlike recurrent neural network or LSTM, long short-term memory. This is the whole input will fed at once. For example, I like Rojava, the whole input will go in single pass, in parallel. Then it goes through input embedding and positional embedding. Then it passes through self-attention. We explained each and every single process of the encoder in previous videos. And then we get add residual, or normalize and feed forward, and then add and normalize, and then we will get the contextual representation of the encoder input in vectors E1, encoder 1, E2, E3, and these are corresponding to I like Rojava. So these fixed encoder representations are stored and reused in every subsequent decoder step as keys, K values, and V values. So we have two matrices, keys and values. So these are the input that will be fed into decoder from encoder. Now, step two, decoder pass, predicting the first word. Okay, so at the test time, the model does not know the target sentence yet. It starts with only start of sequence token. Starts with this token, okay? So the decoder starts with this token. It does the self-attention for the token to attend itself, and it does cross-attention so that query comes from S, from the start token, from the decoder, but then keys and values, matrices, they come from encoder. Okay, so this is what we talk about, what we mean, what's meant by cross attention. Cross attention means what? Means that you have a query from start token, and you have input representation that comes from the outcome of the encoder represented by keys and values, okay? So it computes attention over all source tokens, I like Rojava. Then it will be fed into feed forward neural network, then linear, and then softmax, and then we're using greedy or sampling output will take the highest probability for the token, and that token should be ANA because we entered start token, and then we should get ANA. Now, step three, decoder passes predicting the second word. Well, what we are doing now, we are adding the predicted token ANA, which is predicted from the step two, into the previous token. And the previous token was S token, star token. And now the current one will be added to the input so that it goes to, again, mask self-attention. So S star token attends to itself, and ANA attends to star token and itself, but it cannot see ahab, the word ahab, because that's a future token which will be masked. Now, cross attention block, both tokens generate queries. The S and ANA will generate queries to attend the encoder's output, and encoder's output keys and values. So they will be forwarded to linear, forward, and neural network, linear, softmax, and again, greedy sample, we should get a HEP token predicted. Now, likewise, the same thing, a HEP will be added for the next step to the previous input, which we had it S start token and ANA. Now we will add in the next step a HEP. So now a HEP is added for the in the decoder pass tree, and it will be mask self-attention. So a HEP can attend to itself, can attend to S token, can attend to ANA as well, and itself as well. And then cross attention block queries attend to the encoder, which is keys and values. Then it will be passed to feed forward network, then linear, then softmax. Then we will predict Rojava. Next step, Rojava will be added to this decoder input to be a new input for the system. Now, Rojava was added, and we run through the mask self-attention. We get cross attention with the encoder, keys and values, then feed forward, linear and softmax. Then we will get the output token, which is the end of the sequence. Okay, that's /s. So that's basically what happened in training and testing. But we will try to talk in details about each token in the training and each token in the testing. So decoders input, full grounded truth sentence shifted right. That means start token ana ahab, that will be shifted in the training. Okay, and then in the testing, the list, the input list will grow. In each step, the predicted output token will be added to previous input, and then it will be a new input to the system. Pass is needed, one single parallel pass, but we are using causal mask, and I explain what's causal mask in detail with the example. Here in the testing, we have n sequential passes, so we do it autoregressively. Token by token we add, and we add the predicted token to the previous token, and then it will be fed to the system. Next token source, taken directly from the reference data set, which is a teacher force, which is the training. Predicted by models, previous step, output. What happens here? The prediction will be the highest probability of the token in each row in the matrix. So we take the highest probability because as we have in the decoder, the last process is the softmax, and the softmax will take the maximum or the highest probability in each row to see what is the predicted token is. Now, here we have encoder and decoder during training and testing. So the encoder's role is to process the entire source sentence and create rich contextual representation represented by key values and V values, okay? Two matrices. So input data, the complete source of sentence I like Rojava will be represented by key values and V values, which are converted into numerical embedding vectors. Positional encoding are added to these embeddings to provide sequence order information. The entire sequence is fed into encoder all in once. So this is unlike recurrent neural, unlike LSTM, the whole sentence will be fed to the encoder, and we will get the values. We will get K values and V values, two matrices. So the encoder behaves exactly the same during both training and testing. So it will be in parallel, will be fed the whole sentence. In testing, this pass is executed only once per sequence to generate K values and V values, okay? That's what we said, that the decoder uses these values. Now, in the testing, okay, decoder, unlike the encoder, the decoder operates differently depending on whether it is training or testing. If it is training, which is another word for it is teacher forcing, so the target sequence shifted right, fed all at once. So the whole sentence in the training will be fed in parallel. So there's no sequential here. But what happens, there is a causal masking. So don't forget, and I will try to explain causal matrix in detail in next slides. However, testing phase, which we called inference, it will be done in a mode, we call it autoregressive sequence, which step by step. First, in first step, we feed in start token, and we will get something called predicted token, which is ANA. And then ANA, the predicted token, will be added to the previous step, and they will be fed in the next step to the system. And then the predicted outcome for this input, it will be ahab, that word. Then that word will be added to the previous tokens that we had, which is start token and ahab, so that we can predict next token Rojava, something like that. So that's what we were talking about, auto generation. So and during the testing, the true target transition is unknown. The model must predict the sentence token by token. So, for example, decoder input start, okay, start token. Then we process this one by the decoder, and this token attends to itself, but it cannot attend to other future tokens. So we will predict ANA. And then ANA will be added to the decoder input in the next step. And once it has been added, then it will be fed to decoder. It will be processed, and we predict AHAB. Then AHAB will be added to the decoder input in the step tree, because we have 3 words. So, and then we will get Rojava. And then Rojava will be added. Then the sentence is all over. Then we should get predicted N token, which is /S. So this is more or less about the summary of the training and testing for the example that we had. I like Rojava. For the training encoder, complete source text, I like Rojava in parallel, all token in one parallel pass. In the training, decoder ground truth target, which is start token, ANA, AHAB. Again, all target tokens in parallel pass using causal mask, okay? And I remember this asterisk, and I talk about and I explain in the next slide. So this asterisk, remember this one, signifies some slides that are coming after this slide. So training, again, the whole sentence will be added in parallel, as we said. For the testing encoder, again, complete source text, all tokens in one single pass runs only once. However, in testing decoder, initially we sent start token, then accumulated model prediction, then we will get, sequentially, we will add the predicted to the start, to the previous, and then we get the output. And then again, so it'll go sequentially. It's not in one go. So it's a loop, and then until it stops until we have N token is predicted. So here, what I try to explain the asterisk here, what does it mean all target tokens in one parallel pass using causal mask. So to explain this one, it's a transformer decoder in the training, which we think that all target tokens, the entire target output sentence, is available during training. So the whole target, it's available in training. So one parallel pass, the model processes all tokens simultaneously at one time. So at one time, we will process the target in the training. In one pass, we will feed in um, um, start token أنا أحب all in one pass, one sentence, okay? Rather than one token at a time. So we do it in one pass simultaneously. But however, here we are using causal masking. Each token can be prevented from seeing future tokens. Each token can attend to itself or attends to itself and its previous token, but it cannot see the future. And I give you an example here. For example, I like Rojava, and we try to translate it into Arabic. So here, the source that we have, I like Rojava. This one will go into encoder. The Arabic target inside decoder. So it is start token, أنا أحب Rojava, and end token. So start token, which is start token, أنا is I, أحب is like, and Rojava is Rojava, and this end token, the end token for the start that we started. So the position 1, 2, 3, 4, first position is start token, Ana is the second, Ahab is, and then, so this, during training, the decoder receives the entire target sentence at once from where? From itself. So from the input from the very beginning of the process. However, it also receives I like Rojava from the encoder, which is represented in a contextual manner. So this one also will be will be fed to the decoder as in the form of keys and values. So the decoder predicts the next token for every position simultaneously. For decoder input S, will expected output is Ana. Then Ana will be added to next step decoder input. So your next input will be S plus Ana. Then the decoder will predict Ahab. And then Ahab next time will be added. Then you get Rojava, and Rojava will be added. The whole sentence then future, which is S end. So as you can see, the process all depends. The process all depends on previous words, and decoder computes all of them in one forward pass. Okay. Now, what is causal mask? Causal mask means what? Means the current token can only attend itself, but cannot see أنا أحب رجعة, the whole sentence. And if we are here in Ana, so Ana can attend to itself and can attend to its previous token, but cannot see Ahab and Rojava. Likewise, Ahab can attend to Ana and can attend to S token and can attend to itself, but cannot see Rojava. When you put the Rojava, then everything, when Rojava is given, Rojava can see itself, can see Ahab, can see Ana, and can see star token. And I think there's no future. Everything is seen. So here S, this is the, if this is the row S, the row for, if this is a matrix, and the first row represented by token, star token. So star token can see itself, cannot see Ana, cannot see Ahab, cannot see Rojava. So the feature 4 is Rojava, feature 3 is Ahab, feature 2 is Ana, and feature 1 is S. So the S token can only see itself. That's the causal masking. Ana can see itself in the second, that's itself, and can see S token, which is this one, S token, but cannot see Ahab and cannot see Rojava. Ahab can see itself, that is the third one, it's the third feature, can see itself, can see Ana, its previous, can see also before, after its previous, which is star token. Rojava, all tokens are seen because there is no another token, so everything is seen. So because the whole sentence is completed, there's no future sentence, so that's why all ticked. So Rojava is here, can see Ahab, can see Anna, can see star token. Now, what is the predicted or what's predicted? All four predictions are made simultaneously. So S Anna prediction Ahab, and that's how it works. Now, but there is also one important explanation about how we can um, uh, uh, during the inference, during the testing, when the model actually translating a new sentence, it does not know the Arabic translation yet. So it generates one token at a time. Okay. For example, when we put S uh, token, it will predict Anna. But the next input, it will be S plus Anna. Then we will get Ahab. And then we add Ahab, the predicted token, to the input. Then will be S token, Anna Ahab. Then we will have Rojava. And then we will predict the end token. That's all about the training and inference and the concept of causal masking. I hope that I explained it clearly here. And this is only just the differences between training and inference. Training, teacher forcing, and inference is testing. So stay tuned for the next classes. I hope it was useful. And for more information, see the links below and YouTube channel. I look forward to see you again. Thank you.